Hey everyone, welcome back. Today we're going to be creating a documentation chatbot. This essentially means you'll be able to take your company's documentation or a project's documentation, scrape it with BeautifulSoup in Python, store it in a vector database using Pinecone, pass that information in Pinecone to the OpenAI API, and then create the best answers for the user when they type into the chatbot. The video will be broken up into two parts. The first will be creating that web scraping and storing into Pinecone. The second will be actually creating that OpenAI chatbot. I'll add timestamps within the video if you want to skip around. And if you have any questions as we're going through, definitely ask in the chat. I'll try my best to get the answers to you. With that, let's get started. Okay, so before we actually get into the Python code, let's make sure we understand this at a high level. So we'll see here on the screen, we have 4 steps we're going to take the documentation and then store it into our Pinecone database. And the first you can see is to scrape. So we're going to be using BeautifulSoup in Python to take our documentation pages, scrape the information, and then eventually work through the next steps. On the right side, you can see we have an outline of what a documentation page generally looks like. We have a title, we have headers, and then we have sections of content. The section of content is going to be the most important part because this is where our answers are going to be found. Now, what we're going to be doing with this information is taking it, passing it through to the OpenAI ChatGPT API, and then returning back an answer. The information we pass through helps ChatGPT understand the context to respond back with a relevant answer. Now, let's say we find our answer in header 1, and then header 2 and header 3 have information that aren't relevant to the question. This is not going to be helpful. We're going to be passing OpenAI information that's not needed. So the next step we're going to do is actually chunk out our pieces of documentation. So each section content is going to be broken out into its own piece of information. Think about this at scale. Let's say we have 100 pages of documentation. In those 100 pages, we'll have many, many different pieces of content. Let's say that our answer has 5 pieces of content that are relevant, and those relevant pieces of information come from various different documents. Now we're taking all these documents, finding the best content, and passing it through to the API. Therefore, we should get the best answer in the end. So at this point, we have our sections broken out into chunks. And we're going to try to use this information to pass in the user's question and find the relevant answer. So let's say I ask a question about pets. In this example, I'd want to get back information about dogs and cats and not football and sports. Well, for machines to do this, they don't actually understand text, they understand numbers. So we're going to have to use something called an embedding model. OpenAI provides this model. It essentially allows you to take the context to the left, pass it through, and return back an array of vectors. Now, embeddings are a fundamental concept when it comes to natural language processing and machine learning in general. Essentially, it's a mathematical representation of the words or phrases you find in the left side, and then it passes it back into numbers that a machine can understand on the right. Each word is going to be mapped to a high-dimensional vector in continuous space. So this essentially means there's going to be many, many dimensions going on here for the computer to understand. Now, when we get our results back, we're going to find similarities in the numbers that are returned. For instance, cats and dogs will be more similar to football and sports. If we take a look at this on 2D space, again, this is going to be multi-dimensional in real life, we're going to find that cats and dogs are going to be located in a similar location within the space. Same with football and sports, a little further away than cats and dogs. If we added something like lions are animals which are going to be closer to cats and dogs, while baseball is going to be more closely aligned with football and sports. So again, we can use this when we ask questions to find information and pass back the sections that are most relevant to the question that is asked. Now, once we have all our chunks represented in vectors, we're going to store that in a vector database using pinecone.io. There's many other options out there, but in this example, we'll look through how to use pinecone.io and the API it provides. So now that we have that, let's actually look at the Python code and run through these 4 steps. Okay, so let's jump into the Python code. Here we're in Visual Studio. You can see to the left, we have the web crawler file, which we're walking through now, and then the chatbot, which we'll take a look at after this. So up here, we're creating a class called web crawler. We have our imports up top, and down here, we're going to start off the web crawler. We're going to pass in some URLs. You can see these are the URLs we're actually going to crawl and get the information for. So what we're going to be taking a look at is a company called Starburst Data. It's a very good data lake analytics platform that allows you to connect to various different data sources. You can see here's a list of some of them, and we're looking at the Postgres page. If we scroll through this, you can see we have the title, we have headers, and we have all the different sections of content that I mentioned in the previous section. we have some code here or JSON and pieces of information that may be hard to capture, but we're going to do it. So let's look at the code that makes this actually happen. So we have start. So this function start, we're going to call. We're going to run through our different URLs. And the first thing we're going to do is actually start crawling it. So let's jump into the crawl URL function where we use the first instance of BeautifulSoup. BeautifulSoup, if you haven't used it before, is a great way to actually crawl pages and get the information we need. Request is being used to reach out to the different URLs we're looking for. Again, we're going to be looping through this. So each time we come into crawl URL, we're looking at one single URL. We're going to get the text, and then we're using an HTML parser to get the information we need. That's going to be stored in soup. We're going to get the title. And here we're going to break out the content into what we call classes of MD content. To explain that, within our documentation, we do not want the information here or here. Within this documentation page, we only want the middle. And with this specific div, it's called MD content. Anything that you're looking at might be different. So I would come in here, hit inspect, go to your elements, and look for the different information you need. Here you can see MD content is the middle. If we highlight over this, so very important. Again, any documentation page you use will be different. Now, Starburst has multiple different types of documentation pages. Another one has docs content instead of MD content. So just be aware that when you're creating this yourself, you are going to have to change this to the documentation pages you're looking at. So once we get that information, we're storing it in soup res, and we're going to pass it into a function called getTextChunks. When we get into here, this is the actual portion where we're going to get the chunks of data within each section. So here, first thing we're going to do is find all the headers. Again, the sections are going to be between all the different headers. And we're going to loop through all the different headers we have. We're going to get the information or the text of that header. And we're going to look at the header right next to it as we're going to get the information in the middle of each header. So once we have that, we're again going to loop through this. Where you can see here, we're going to find the elements between the header and the next header. So if we look at our documentation page one more time, we have a header here and we have a header here. We're going to be looking at the content information right in the middle of these two. So essentially, we're going to be looping through it, finding this information. That's what this code is doing here. So we're going to go through it. It's going to look for more headers, and it's going to get the text in between the different headers. To get that, we're going to append the chunk of text to text chunk. We're going to break out of that. So we're going to keep looping through that as many times as we need until we get all the different headers. Once we get to the last header, we're going to treat this one a little differently because it's the end of the file. So we're just going to take that and pass it into text chunks. Once we have all the different text chunks, we're going to turn it back to crawl URL. Once we have those text chunks, we're going to store it into a pandas data frame. We're going to remove all the new lines. And we're going to use something called a tokenizer. The tokenizer is very important here. If we scroll up to the top, you can see we're using something called tick token. This is something that OpenAI recommends you use. Essentially, it's going to allow us to get the information we need when it comes to the amount of tokens each of these sections are going to contain. Again, a token is a representation of the text. If you've ever used OpenAI's API before, the currency is essentially in tokens. So if you have 1,000 words, that's going to be represented in an amount of tokens. Let's say 2,000 tokens. Those tokens are going to be the cost associated with that API call. So at this point, we've crawled the URL, we've broken it into chunks, and now we're returning it back to our function here, where we now have a data frame filled of the chunks, and we have the title of that URL. If we don't have any data frames, we're going to essentially say we're unable to parse it. If we do, we're going to try to find ways to shorten it. So let's jump into this function really quickly. It's called getShortened. So here we have that data frame. Remember, this is containing all our different chunks. We're going to loop through that through the rows. And down here, very importantly, we're going to be looking to see if the amount of tokens in that section is more than max tokens. We haven't talked about this yet, but max tokens is going to be initialized up here in the init function of this class. You can see here we're setting it to 500. Essentially, this means that you don't want to have a subsection or a section of content that is thousands and thousands of tokens long. One, because there's an API limitation on how much you can pass through to OpenAI. And two, it's very unlikely you need all that information when you get the answer. So we're going to take that section, if it's very long, and actually break it down even further. Let's run back down here, and we're going to look at if this section is greater than the amount of chunks. We're going to check if this section is greater than the max amount of tokens. We're going to split it into many. So if we go to split to many, we're now essentially going to take that chunk, loop through it, and split it until it makes the amount of max tokens. So here it's 500. Let's say the original section was 1,500. We'll break it into 3 different subsections based off the max of 500 tokens. So that's what this function is going to be doing here. We get shortened, and essentially, again, we pass it through and return a new data frame with these shortened sections. So now that we have these data frames, we are going to pass it through to our Pinecone database. So let's jump up into Pinecone get embeddings. We're here. We have the Pinecone embeddings. Here we're just making a title. We're replacing some information. You're not allowed to pass through all letters and context. So here we're replacing that information. Pretty common Python code. Now we're actually going to create the embeddings. So here, if you remember the diagram, we take the context on the left in our sections, we pass it through the embedding model, and here we're going to do that and save the results in data frame embeddings. So we're passing in the information here. The embedding model is the OpenAI embedding model, and we're returned back that array of vectors that we saw in the diagram before. Once we have the data frame, we're going to iterate through that, and we're going to create a new array called embeddings. This essentially is a JSON or an object where we're going to have the title, we're going to have the values, which is the embeddings, and very importantly, we're going to have metadata. The metadata is going to contain the URL. I like to keep the URL so I can say in the chatbot, this information was found at this URL. We have the text, so we need to pass through the text of that section. So again, the section is going to be broken down into text and vectors. Vectors are going to be used for the computer. Text is going to be used for the humans. So here we're passing in the text, and then company. If you had multiple companies, you could pass this in. Remember, we're working with Starburst data, so we're going to pass in the company Starburst. We're going to check now if we have a Pinecone database essentially already created. In Pinecone, they're called indexes. We're naming ours Starburst. So if Starburst is not created, I want to create one. We can look at what it looks like within Pinecone very quickly. This is Pinecone. You can see indexes. I created one called Starburst. If you wanted to create one, create it here. Very importantly, make sure you have the dimensions 1536. This is something here, you can see it, that we need for OpenAI. Once you create that, you can see the vectors that are stored within the 3 pages of documentation. I have 97. So just make sure you do that correctly. If you don't have it, again, this will create it for you. If you run the code, it'll create an index called Starburst with dimensions 1536. Once we do that, we're going to get the index from the Pinecone API, and we're going to upsert the embeddings. So here we're going to pass in this information where we pass in the embeddings, the metadata, and the title into our Pinecone database. And just like that, we've run through it all. We've gone through the scraping of the documentation. We've shortened it into chunks. We've even made it shorter based off the max amount of tokens we pass through, which in this example is 500. And then we pass it to our embedding or our Pinecone embeddings function to, again, store it. So this is step 1. The next step would be to actually take the content that we have within Pinecone and use it to pass through to a chatbot. And we're going to look at that now. Okay, so now that we have our Python code created for our web scraper, we want to find ways to use the information we have in Pinecone and use it within our chatbot. Here are 4 steps we're going to run through to make that happen. We're going to capture the information from the user. We're going to look it up in Pinecone. We're going to return back the 5 closest results, and we're going to ask ChatGPT for the answer. So let's run through it. The first step, the user is going to ask a question. Again, this is going to be in text, and we need to find a way to correlate it with the information in Pinecone. So to do that, we're going to use the same embedding model we did within the web scraper and use it within our chatbot. So we're taking the text of the question, embedding it And we're going to again get an array of vectors that we can utilize. So we're going to take those vectors and make a Pinecone query to our vector database. And we're going to get the 5 closest results and add that to the context of our ChatGPT API request. So the Pinecone is going to return back some results. And you can see here, we're going to make a context for ChatGPT. The header is something that we're going to use to illustrate why this ChatGPT is working. We're going to have the context, which is going to be the 5 results back from Pinecone. We'll see how that works. And then we're going to reiterate the question in a query at the bottom. Essentially, this is going to be a long string that we pass back in the API, so ChatGPT can make the question and answer the best way possible. So once we do that, we create this string, we pass it into the ChatGPT API, and we get the response for the user. A lot of the hard work was already done in storing the information in Pinecone. Now we're just getting that information, creating context for the ChatGPT API, and responding to the user. So let's jump into the code and see how that actually works. Okay, so now we're back in Visual Studio Code looking at chatbot.py. Before we were looking at webcrawler.py, now we're looking at chatbot.py. So in here, we're again going to create a class called chatbot. And down here, we're going to start the chatbot just like we did before for the web crawler. The first thing we're going to do here within start is create an input where we're saying, hello, how can I help with Starburst data? Type exit to close the chat, and then have an icon here to indicate that the user should type. We're going to run through a while loop. If it says exit, we're going to exit it. If not, we're going to answer the question with this function we'll look at in a second and have an input. So let's just quickly look at what this looks like when we run it. You can see, hello, how can I help with Starburst data? Answer the chat. I can say, how does Postgres work with Starburst? So here I ask a question. The chatbot is going to answer back here. It takes a second to get the information from the API. You can see here, we just got information back about Postgres. If you recall, this is the information we stored within our vector database, and it gives back a really nice answer about information that we found in that content page. So that's great. Let's look at how we did that. So we're going to go to answer question. And here you can see we have a create message. So the first thing we're going to do is create the message. When we run in here, this is going to be that part where I mentioned we have a header, the context, and the question. So we're going to create the context first. So we're going to go up here, and we're going to open up the embedded API that we called in the web scraper, if you recall. So we're going to pass in the question. The query here is a question that was asked by the user. So in this case, it was, how does Postgres work with Starburst? We're going to pass that into the embedding model, and it's going to return back those vectors that we saw before. We're going to look for the Pinecone index of Starburst that we saw earlier. And here, we're going to make an index query, or a Pinecone query. We're looking for the top 5 results. We're going to pass back the metadata. Again, very important, because this contains the text of the actual information that's being passed through. And this is where the results are going to be stored in vector response. If the vector response length is 0, meaning we didn't get anything back, we're just going to return back and say, I don't know the answer. If it did return, we're going to loop through the results. Again, there should be 5 different sections that are returned here at max. And we want to loop through that, look at the text, and then just make it into one long string separated by spaces. So we're going to have one long string containing 5 different sections of content in here, and we're returning that back as the context. So here again, we have the context now. We created that. And we're going to come down here and have the header. And I'm just going to create a header here that says, answer the questions in the conversation using the context below. Again, the context is the thing we just created. You are an expert on Starburst data and a friendly assistant. Do not instruct the user to read the docs, but instead explain the answers in a concise manner. If the answer is not known, say, I don't know, as an appropriate answer. Write code or YAML files surrounding it with these different indications, something you'll typically see in Markdown. We'll also have the question again. So it's the header, the context below it. Now the question, how would you answer the below question if you were instructor at Starburst data? And then the query, which is the actual question that was asked through. So all of this creates a large string that is going to be passed into the OpenAI API that we're going to see right down here. So we created the message. We're going to pass in the message as a user role. So the system, again, you're just indicating what's going on here. You are Starburst Data and Trino. Very helpful and joyful is how I want to make my responses. Passing in the question to the API. Using the chat completion create method, we're going to pass in the GPT model. We haven't looked at that yet. If we look at the init file, I'm using the 3.5 turbo. You can use ChatGPT 4 if you'd like. And the embedding model we've been using this entire time is embedding ADA 002. So we have that information. We get back the response, and it's going to be returned in chunks. So essentially, we have streaming on here. If you don't want it to be returned in chunks, you can return streaming as false. Essentially, if you've ever used the ChatGPT as a web app, it comes and it looks like it's actually being typed out. That is because it's streamed. So I just wanted to call that out. Here, we're going to return the chunks and return it back to the page as we see down here. So here we have it working, and that's a response. We can say, how do I add Postgres catalog to my YAML file? So this is a more specific question. Let's see if it answers. You can see here it's streaming it out. It's giving the instructions here very nicely. It wrapped the YAML in this code that we specifically asked for. It's telling us how we can add it, and it's giving some really good details. So right now we have this chatbot working with the information we have within our Pinecone database. If we wanted to exit just like that, we now exit our chatbot. So we have this working really well. Hopefully this is helpful in understanding how it works. One thing I do want to call out is there's no memory going on here. This is something I can create another video on if interested. So essentially, you need to ask each question as something new. So with that, we've created our chatbot. We started with scraping the information, stored it in Pinecone, and then used that within ChatGPT. Hopefully, it's helpful in understanding how all of this works, and you are able to follow along and create your own chatbot. From here, you can create things like Slack bots, Discord bots, whatever, to allow users to access it, maybe even create your own UI. Let me know in the comments how you plan on using this, if you're able to follow along, or any suggestions of videos we should create in the future. If you liked it, give it a thumbs up. And with that, I'll talk to you all later.